Hey guys, in this video I want to show you how you can use NumPy and SciPy to obtain the inverse of a positive definite matrix without actually calling numpy.linalg.inv or scipy.linalg.inv. There's a different way, there's a more numerically stable method that we can exploit to obtain the matrix inverse. So what I've done here already is construct a positive definite matrix. And the way that I know it's going to be positive definite is because I've added this small amount of numerical regularization to the diagonal. Okay, and you can see that I'm using np.I, and I have a positive definite function, which is this Gaussian RBF kernel. So anyway, what I can do now is actually compute the Cholesky decomposition of this matrix C. To do that, I'll do spla.cholesky input matrix C. Now, what that means is we have a matrix, and I'll make this lower equals true, a matrix L such that C equals L times L transpose. Let's make sure that's true. Python-i inv.py, we have the matrix C, and then the claim is that L dot L transpose is C, and that looks to be true. Okay, so now what this means is if I want to compute the inverse of C, you may remember that there's a property of inverses that causes them to reverse the order. So we'll have inverse of L transpose times inverse of L. And then you may also remember from algebra that we can switch the order of inverse and transpose. So we'll have inv L transpose instead of L transpose within an inverse. Okay, so now what this means is if we can obtain the inverse of L, then we can compute the inverse of C. So how can we obtain the inverse of L? Well, it's pretty straightforward. We can use another method within the SciPy linear algebra library called solve triangular. And our input will be L, and our input will be the identity matrix, and then we'll set lower equal true. And then if we run this, we can do L times L transpose, and we're going to get something that's numerically close to the identity matrix. And then we can compute C inverse. Do C inv equals L inv transpose multiplied into L inv again. And then if we do C inv at C, we should get something that looks like the identity. And I think indeed it does. So this is a pretty numerically stable way to obtain the inverse of C when it's positive definite without actually computing scipy.linalg.inv or numpy.linalg.inv. And I think you'll find it to be more numerically stable in that respect. So thank you so much for watching. If you like this video, be sure to comment, subscribe, and I'll see you guys in the next one. Bye.